All right, well, fifth graders, today we're continuing along here in Chapter 1. We're looking at Lesson 1.3 today. I want to start here first with a little bit of vocabulary. We have these exponent numbers here. And this, anytime you get a base number, that's what this is referred to, the base, with a little number here in the top right. It's kind of what we refer to as exponents. And we'll talk a little bit more about what this actually means here in a little bit. But first, just a little bit of vocabulary. When we have the number 10 to the power of 7, we also might say this as 10 to the 7th power. But for the most part, I will say a number like this as 10 to the power of 7. And so there's three terms. The base number. Well, the base number is 10. All right, that's kind of our main number. And so that's what we refer to as our base number. Our exponent number is the little number there at the top right, and so we're going to refer to our exponent as 7. And then it asks for the power. Well, the power is just the whole thing, 10 to the power of 7. So that's pretty self-explanatory. Now, when we get something like this, 10 times 10 times 10 times 10 times 10 times 10, you're going to get a situation where it's going to ask you to write a number like this as a power. And essentially when you write things as a power or with exponents, you're basically saying how many times are you multiplying this number out. And so I see that I have 10 times 10 times 10 times 10 times 10 times 10. All right, so my base number is 10. And how many 10s do I have? So I just count them. 1, 2, 3, 4, 5, 6. So I have 10 to the power of 6. Now, my next section here says to find the value of the expression. So they're giving us some different expressions. And this first one here is 10 to the power of 4. Okay? So I say this as 10 to the power of 4, which means essentially I'm taking 10 and writing it out as it's being multiplied 4 times. So when I have 10 to the power of 4, I'm going to write that as 10 times 10 times 10 times 10. And so that's how you would write 10 to the power of 4. Now, 6 times but it's telling me here to find the value of the expression. So when I just write the multiplication problem, I can't really just leave it at that. I have to find the value. So in other previous lessons, we've talked about our zeros trick. So I can just think 1 times 1 times 1 times 1, which is 1. And then I'm going to add the 4 zeros, 1, 2, 3, 4. So I'm going to add 1, 2, 3, 4, 10 zeros, 10,000. And I can also think of this as 1 with 4 zeros after it. So anytime we have 10 to the power of 4, I can think of it as a 1 with 4 zeros after it. 10 to the power of 5, a 1 with 5 zeros after it. So that's another way you can think of it when 10 is the base number. Now the next one is 6 times 10 to the power of 2. So I can think of this as 6, and then 10 to the power of 2 is a 1 with 2 zeros after it. Well, a 1 with 2 zeros after it is 100. So essentially this is 6 times 100. Once again, I utilize my zeros trick. 6 times 1 is 6. I add the 1, 2 zeros, and I get 600. That's the value of the expression. Last one in this section, 5 times 10 to the power of 5. Well, I can start with 5. And since I have 10 to the power of 5, I can think of that as a 1 with 5 zeros after it. So I'm going to put 1, then my 1 zero, 2 zeros, 3 zeros, 4 zeros, 5 zeros. And I'm going to count back as 3, 1, 2, 3. Set up with a comma there, 5 times 100,000. Once again, I can utilize my zeros trick, 5 times 1, which is 5. add in my 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. I get 500,000. Sure enough, 5 times 10 to the power of 5 is 500,000. All right, so that's finding the value of the expression. Now, to kind of backtrack just a little bit, you're going to have one section where you're going to be given some of these multiplication numbers in patterns. And we're just going to look at one real quick here. It's going to tell you to find each product, use patterns to help. And they're all going to look like this. You're going to see a one-digit number, and then it being multiplied by 10, 100, 1,000, or 10,000. And I'm going to do the same thing that I just did on the previous one. I'm going to think 7 times 1 is 7. And then I'm going to add the 1, 0, and I get 70. You're going to start to see a pattern. Well, 7 times 1 is 7. Add the 2 zeros, I get 700. 7 times 1 is 7. Add the 1, 2, 3 zeros. 1, 2, 3, 7,000. 7 times 10,000. 7 times 1 is 7. Add the 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. And I can, for here, I should probably get a comma. 1, 2, 3. Counting backwards, I get 70,000. So that's pretty basic, but there you can see how those patterns will work. Okay, so my next part here, as I'm moving right along with our other topics, tells us to rewrite the number as a whole number multiplied by a power of 10. So once again, rewrite the number as a whole number multiplied by a power of 10. So I'm now doing the opposite. I'm not taking a multiplication problem and finding an answer. I'm taking the product, or the answer to a multiplication problem, and turning it into a multiplication problem, or just a power. Well, here I have 10,000, and so when I have a number like 10,000 or 100,000 or 100 or 1,000, I can just write this as an exponent with a base 10. So remember, when I have 4 zeros here, so it's 10 to the power of 4, that is a 1 with 4 zeros after it. And sure enough, if I did 10 times 10 times 10 times 10, I would get 10,000. Now number 2 is a little bit different. I get the number 90, okay? So I know the first number in my multiplication problem is going to be 9. Now 9 times what is 90? Because it says we're going to be writing it as a power of 10, okay? So when I do a power of 10, okay, I'm going to have 9, and so I know it's either going to be, so I'm going to think, well, 9 times what is 90? Well, if I'm going to do 9 times something is 90, I can think 90 divided by 9, and that's 10. So it's going to be 9 times 10 that makes 90. But it wants it written as a power. So it's just 10, which means I'm going to do 10 to the power of 1. Okay, and I'm just going to write that as 9 times 10 to the power of 1. Now I want to backtrack here to number 1 and just let you know, I will accept 10 to the power of 4 as an answer. But if you were to write this as 1 times 10 to the power of 4, that would also be okay. But I do want you to see that anytime it starts with 1 and it's a bunch of zeros, it can just be written as a base 10 exponent. And if you just put 10 to the power of 4, that's okay too. Because you already know as a 5th grader that anytime you take 1 times something, it's going to equal whatever that other number is. All right, last one for this section, 7,000. So since it's 7,000, it's going to start with 7. And so 7 times what is going to equal 7,000? Well, I'm going to think about 7,000 divided by 7. Well, that's going to be 1,000. So it's going to be 7 times 1,000 that equals 7,000. Okay, that makes sense. But I need to multiply it by a power of 10. So I have to actually make this a base 10 exponent. So my 7 is going to stay the same. And since there are 3 zeros here in 7,000, I'm going to write it as 10 to the power of 3. Because 10 to the power of 3 is a 1 with 3 zeros after it, which is what 1,000 is. And sure enough, if I was to do 10 to the power of 3, which is 10 times 10 times 10, and I'll even just write that out so you can see it, that would equal 1,000. All right, so our last section, write the number in standard form. So here I'm getting almost an expanded form sort of problem, and I need to actually solve and see what this equals. So you're going to get some problems that look like this. This first one is 4 times 10 to the power of 2 in parentheses, plus 7 times 10 to the power of 1. Well, I'm going to think about 4 times 10 to the power of 2. And so we know it's going to be 4. Okay? And 10 to the power of 2 is going to be a 1 with 2 zeros after it, which is going to be 100. And I should be able to figure out that 4 times 100 is going to be 400. 4 times 1 is 4. Add the 2 zeros on there. So then I'm going to add this next part, which is 7 times 10 to the power of 1, which is going to give me 7. And 10 to the power of 1 is going to be a 1 with 1 zero after it. Well, anytime you have something to the power of 1, it's just that number. 10 to the power of 1 is just 10. 8 to the power of 1 is just 8. 12 to the power of 1 is just 12. Okay? So we kind of think about that. Now 7 times 10, I should be able to figure that out. 7 times 1 is 7. Add the 1 zero, I get 70. But I need to actually find the whole thing. So I'm actually left with 400 plus 70. Well, 400 plus 70, I should be able to realize equals 470. All right? So this last one, 8 times 10 to the power of 3 plus 6 times 10 to the power of 2 plus 4 times 1, or sorry, 4 times 10 to the power of 1. All right, well, let's break this down. First, with 8 times 10 to the power of 3, I'm going to start with 8. 10 to the power of 3 is going to be a 1 with 3 zeros after it. And I see that it's 8 times 1,000. Well, 8 times 1,000, I should be able to figure out is 8,000. 8 times 1 is 8. Add the 3 zeros, I get 8,000. Now, I look at this next one, 6 times 10 to the power of 2. That's the next part. Well, so it's going to be 6 times 10 to the power of 2. Well, 10 to the power of 2 is going to be a 1 with 2 zeros after it, or 6 times 100. Well, 6 times 1 is 6. Add 2 zeros gives me 600. This last part is 4 times 10 to the power of 1. So I'm going to start with 4 times 10 to the power of 1, which is going to be a 1 with 1 zero after it, which is just going to be 10, as we just talked about a minute ago. Anything to the power of 1 is whatever the base number is. Well, 4 times 10, 4 times 1 is 4. Add the 1 zero, I get 40. And so that leaves me with 8,000 plus 600 plus 40. Well, 8,000 plus 600 plus 40 should be 8,640 with a 0 in the ones place. And I see that as my final answer. All right. Have a good day, 5th grade. Good luck on this assignment. Bye.